Hello everybody. Well, let's begin our discussion over the questions from sequences and series. If a, b, c are in GP and a to the power 1 by x equals b to the power 1 by y equals c to the power 1 by z, prove that these x, y and z quantities written over here are actually in GP. So we have a, b, c are in AP, we have to show that x, y, z, a, b, c are in GP, we have to show x, y, z is in AP. I am given that a to the power 1 by x equals b to the power 1 by y equals c to the power 1 by z. Suppose all these quantities are equal to k. This implies a to the power 1 by x is k and b to the power 1 by y is k and c to the power 1 by z is also k. If you take x power both the sides, you get a equals k to the power x, b equals k to the power y, c equals k to the power z. Here I have taken x power both sides, here I have taken y power both sides, here I have taken z power both sides. I have got this particular thing. Now I am given a, b, c is in AP. A, b, c, they are in actually GP. This implies b square equals AC. If three quantities are in GP, that means square of the middle term is equal to product of the first and the third term. So b square equals AC. B square means k to the power y whole square equals a into c, that is k to the power x into k to the power z, which implies k to the power 2y equals k to the power x plus z. Bases are same, we equate the powers. So you get 2y equals x plus z, which obviously implies that x, y, z are in AP. Because three quantities are in AP if and only if twice of the middle term is equal to sum of the first and the third term. So A, B, C were given in GP and that implied x, y, z are in AP. Clear? Moving to the next question we have, if n arithmetic means are inserted between 20 and 80 such that the ratio of first mean to the last mean is 1:3, then find the very value of n. Now I am taking this 20 as A and 80 as the quantity B. In this situation, I am saying let the n arithmetic means be A1, A2 and so on an, such that A, A1, and so on an, B, they are in AP with common difference equal to D, with D as the common difference. A I have taken as 20 and B is given to me as 80. This is a sequence which is an arithmetic progression. First term is 20, common difference is denoted by D. I know that what is the formula of D for this sequence to be an AP. If from A1 to AN are the n arithmetic means inserted between 20 and 80, it is B minus A upon n plus 1. So it is 80 minus 20 upon n plus 1, that is 60 upon n plus 1. I am given that ratio of first mean to the last mean. This is the first mean, this is the last mean. Please understand the first mean actually is the second term of this AP and this is the n plus 1th term of this AP. This is the first term, then second term and so on. This is the n plus 1th term, this is the n plus 2th term. So first mean is the second term of this AP and nth mean is the n plus 1th term of this AP. I am given that ratio of first mean to the last mean is 1/3, which implies second term of this AP, its ratio with n plus 1th term of this AP is 1/3. Second term of this AP, you know it is written as first term plus the common difference, and n plus 1th term is A plus n plus 1 minus 1, that is n, A plus nd, this is given as 1/3. What is A plus D? A plus D, A is actually 20 and D is 60 upon n plus 1. So you will be having 20n plus 20 plus 60. that is 20n plus 80. So 20 common, n plus 4 upon n plus 1, and a plus nd is a plus n times 60 upon n plus 1. This is 20n plus 20 plus 60n, that is 80n plus 20. 20 comes out, you get 4n plus 1. See, over here you get 20n plus 20 plus 60n, so you get 20 plus 80n. 20 comes out common, 1 plus 4n. So you get 1 plus 4n or 4n plus 1 upon n plus 1. Fine. You have that this ratio is 1 by 3. So this ratio is 1 by 3, 20 n plus 4 upon n plus 1 whole upon 20 4n plus 1 upon n plus 1. Ratio of these two quantities is given to be equal to 1 by 3. 20 cancels out, n plus 1 is out. What are you left with? Because this is n plus 4 upon n plus 1 divided by 4n plus 1 upon n plus 1, that is n plus 1 upon 4n plus 1 if you multiply, and therefore you get n plus 4 upon 4n plus 1 equals 1 by 3, which implies 3n plus 12 equals 4n plus 1. Eventually you get 12 minus 1 is 11 and 4n minus 3n is n. So n comes out to be 11. It is this value of n for which if n arithmetic means, it is actually 11 arithmetic means if they are inserted between 20 and 80, then the ratio of the first mean to the 11th mean will be coming out to be 1 by 3. Okay? Moving to the next question we have, if A, B, C are in AP and X, Y, Z in GP, show that this quantity is equal to 1. You just need to know the basics related to AP and GP and you would be through with any question on that. A, B, C are in AP. A, B, C, they are in AP. This means that twice of the middle term is equals to sum of the first and the third. X, Y, Z are in GP. This is if and only if square of the middle term is equals to product of the first and the third term. Consider the left hand side which you need to actually show to be equal to 1. It is x to the power b minus c into y to the power c minus a into z to the power a minus b. Let's manipulate according to our given facts. Y will be replaced by root z, root xz. If y square is xz, y will be replaced by root xz. So I am going to write it as root xz whole to the power c minus a, z to the power a minus b. This can be written as x to the power b minus c, root x to the power c minus a, root z to the power c minus a, z to the power a minus b. Simplified further, this is x to the power b minus c, this is x to the power c minus a by 2, z to the power c minus a by 2, z to the power a minus b. Bases are same, add the powers. What do you get? X to the power b minus c plus c minus a by 2, and here you have z to the power c minus a by 2 plus a minus b. Eventually this gives you what? 2b minus 2c plus c, and then this is minus a upon 2, z to the power c minus a plus 2a, so this is plus a minus 2b whole upon 2, x to the power 2b minus a plus c whole upon 2, z to the power a plus c minus 2b whole upon 2. Please go back to the given facts. A plus c is same as 2b. So this is 2b minus 2b whole upon 2, 2b minus 2b whole upon 2. This is x to the power 0 into z to the power 0, that is 1 into 1 and that is 1, that is what you wanted on the right hand side, and that is what proves your given question. Next we have A, B, C, D and P are different real numbers such that this expression is less than or equal to 0. Show that A, B and C and D are actually in GP. If I need to show that A, B, C, D, the sequence of 4 terms is in GP, that means I have to show the ratio of any term with its immediate preceding term is a constant. I have to show B by A equals C by B equals D by C. That's my aim. Right now we have A square plus B square C square into P square minus twice of AB plus BC plus CD whole into P plus B square plus C square plus D square is less than or equal to 0. If this expression is less than or equal to 0, just consider the left hand side of this given expression. A square P square, I am just writing it in the manipulated form. A square P square minus 2A PD minus 2A PD plus D square. Fine. Yeah. Next you have what? A square P square. Here you have A square plus B square. This is plus C square. So keep it as plus C square. Then you have plus B square P square plus 2BPC plus C square. Then you have plus C square P square minus, this is minus 2CDP plus, then you have D square. What actually I am trying to say is this is A square P square minus 2AP B plus B square. After that we have B square P square minus 2BCP plus C square. Then you have C square P square minus 2PCD plus D square. This actually is what? This is AP whole square and this is B square. Can I write this as AP minus B whole square? Right? Here you can write as BP minus C whole square and this will be CP minus D whole square. I am just manipulating the left hand side. When I do that, I know this quantity is greater than or equal to 0, greater than or equal to 0, greater than or equal to 0. Sum of 3 non-negative terms is always non-negative. 1 is giving you that this expression is less than or equal to 0. Then you manipulated and saw that actually it is greater than or equal to 0. By 1 and 2, you have that this expression is actually equal to 0 and this expression is nothing but this expression, that means AP minus B whole square plus BP minus C whole square plus CP minus D whole square is equal to 0. Sum of 3 non-negative terms is equal to 0 if and only if each of these terms is equal to 0. That means AP minus B whole square is equal to 0, which is only possible when AP minus B is equals to 0 and BP minus C is equal to 0 and CP minus D is equal to 0. Square of a real number is 0 if and only if that real number itself is 0. This implies AP is equals to B, or what I can say, B by A is equal to P. Then you have BP is equals to C, or C by B is equal to P, and CP is equals to D, or D by C is equal to P. That is D by C equals C by B equals B by A equals P. This means what? In order to show A, B, C, D are in GP, I needed to show D by C equals C by B equals B by A. I am getting D by C equals C by B equals B by A equal to the same quantity P. So this implies A, B, C, D are in GP. Clear? Next question says what? Let's see. F is a function satisfying f of x plus y is fx into fy for all xy in the set of natural numbers. F of 1 is given to you as 3 and summation fx x going from 1 to n is 120. Find the value of n. Please get this very, very clear that x and y are coming from natural numbers. You pick up any natural number, what is the feature? Suppose 7 I pick up as a natural number, 7 can be written as 1 plus 1 plus 1 7 times. 21 natural number can be written as 1 plus 1 plus 1 21 times. X is a natural number, it can be written as 1 plus 1 plus 1 x times, right? So, as x is a natural number, x can be written as 1 plus 1 plus 1 x times. Therefore, f of x is f of 1 plus 1 plus 1 x times. But it is given that f of addition of two things is product of the function being applied on those two things. So, f of 1 plus 1 plus 1 x times is f of 1 into f of 1 into f of 1 into f of 1 x times by the property given that f of x plus y is fx into fy, right. This means f of 1 whole to the power x, that is what happens, but f of 1 is given to be 3, so this is 3 to the power x. I have got f of x is actually 3 to the power x. Now, I am given that summation f of x, x going from 1 to n is 120. That means it is given summation 3 to the power x, x going from 1 to n is 120. Till now there is no relevance of AP or GP. If you open the summation up, you get 3 to the power 1 plus 3 to the power 2 plus 3 to the power 3 plus 3 to the power 4 plus and so on plus 3 to the power n is 120. The moment you see the left hand side, it is GP with first term 3 and common ratio 3. This is the sum of finite terms of a GP, sum of n terms of this GP, which is given by A. A is the first term, Rn minus 1 upon R minus 1. R is 3, common ratio, to the power n minus 1 upon R minus 1. Fine. 3 minus 1 is nothing but 2. You eventually get 3 to the power n minus 1 is 120 into 2 upon 3. This is 80. So, you get 3 to the power n equals 81. 81 is nothing but 3 to the power 4. Bases are same. You equate the powers. You get n is equal to 4. And that is what is the value of n for which summation x going from 1 to n fx is 120 when fx is 3 to the power x. Next question says that the product of first 3 terms of a GP is 1000. Now, they are not giving you the 3 terms. They are saying that there are 3 terms of the GP whose product is 1000, and then a condition is given and a question is being asked. Condition is that if 6 is added to the second term, 7 added to its third term, then the terms actually become an AP. So, we know how to select 3 terms of a GP. Let the terms in GP be A by R and AR. It is given that the product of these 3 terms is 1000, RR cancels out, you get A cube is 1000, which implies A is 10. Then it is given that if 6 is added to the second term, first term remains as it is, second is A by R. If 6 is added to the second term and 7 is added to the third term, then I have to show that this is an AP. Or basically, we do not have to show, we are given that this is an AP. And this sequence of 3 terms is an AP. That means twice of the middle term is equal to sum of the first and the third term. So, twice of A by R plus 6 is equals to A plus AR plus 7. A is 10. Given to you already. So, what can I say? That when 6 is added to its second term is A by R. When 6 is added to the second term and 7 is added to its third term, then the sequence becomes an AP. So twice of the middle term is sum of the first and the third term. So here you have twice of A is what? 10 by R plus 6 equals 10 plus 10R plus 7. Clear? How basically do you move from this stage to evaluate that particular R which is going to give you your GP, because A is already there with you. A is already there with you. From this equation somehow you need to calculate the value of R, and then with the help of this A and that R you need to compute the entire GP. How are you going to actually use this to get the GP? Try to think upon it, and then we are going to get back to the same very question. Okay, so in here whenever randomly we are choosing 3 terms of a GP, the first term basically is kept as A by R, second as A and third as AR. So product is not going to be altering at all. If I do that, this would actually mean A by R into A into AR, which would again be giving me A as 10. Here I will be having A by R as the first term, A as the second term and AR as the third term. Now when 6 is added to the second term, 7 is added to the third term, then you get this resulting sequence in an AP. This means twice of the second term is sum of the first and the third term. So this implies twice of A plus 6 is equal to A by R plus AR plus 7, right? 10 plus 6 is 16, 16 into 2 is 32 because A is 10. This is 10 by R plus 10R plus 7. 32 minus 7 gives you 25 equals 10 by R plus 10R. This gives you 5 equals 2 by R plus 2R. I just took out 5 common, this 5 common from the left hand side, 5 common from the right hand side. This gives you what? 5R equals 2 plus 2R square. This gives you 2R square minus 5R plus 2 equals 0. 2R square minus 5R minus R, or rather than that I should write over here plus 5R minus R, because 5 minus 1 is 4 and 5 into minus 1 is minus 5, plus 2 equals 0. This is, or rather than that let me keep it as, because I want 4, so this is 2R square minus 4R minus R plus 2. Right? This gives me 2R common, R minus 2 minus 1, R minus 2. So this gives me R minus 2 and 2R minus 1. So R is 2 and R is 1 by 2. Therefore GP is what? A by R, with R equals to A by R, A into R, that is 5, 10, 20, or it is A by R, 10 upon 1 by 2 is 10 into 2, A by R, A into R, that is 20, 10 and 5. Clear? Moving to the next question, we have find the sum of this following series. Now we have done something like this in our regular lectures as well. I know this is neither an AP nor a GP, so I will be manipulating it. 5 plus 55 plus 555 and so on up till n times 5. I have to add and deliver the sum. 5 can be taken out common, you are left with 1 plus 11 plus 111 plus and so on 111 n times. Still it is neither an AP nor a GP, so what we do? Divide by 9, multiply by 9, so you get 99, then 999 and then 999 n times. Again neither an AP nor a GP, so what we do? 9 can be written as 10 minus 1, then 100 minus 1, then 1000 minus 1 10 to the power n minus 1. Now what you do, you club the like terms. 10 plus 10 square, 100 is 10 square, 1000 is 10 cube, 10 to the power n minus 1, 1, 1, 1 being added n times. This is n times. 1 added n times obviously gives you n as the answer, right? Next you have what? 5 by 9 is already there outside. If you focus over here, this is a GP with first term 10, common ratio 10. So your answer will be 10 to the power n minus 1 upon 10 minus 1 minus n. So eventually what you get is 5 by 9, 10 to the power n plus 1 minus 10 minus 9n and 9 outside. So this is 5 by 81, 10 to the power n plus 1 minus 10 minus 9. Here I have just used the same formula, that is sum of n terms of this particular GP with first term 10 and common ratio 10. Next question says the ratio of the sums of m and n terms of an AP is m square is to n square. Show that the ratio of the mth and the nth terms is this. Let's begin. Sum up to m and sum up to n terms of an AP. Sum up to m terms, sum up to n terms. Ratio is m square by n square. That means what? m by 2, 2a plus m minus 1 into d upon n by 2, 2a plus n minus 1 into d. This is m square by n square, right? Now in here, this 2 cancels out, with this m cancels out, with this n cancels out. You have 2a plus m minus 1 into d into n is equal to 2a plus m minus 1 into d into m. If you open it up, you get 2an minus 2am equals d m minus 1 minus d. This is actually m minus 1, and this into m, this is n minus 1. Right? 2a plus m minus 1 into d into n and 2a plus n minus 1 into d into m. So here it will be d n minus 1, because that is what is here. See, 2an minus 2am, and here it is dm n minus 1 minus d n m minus 1. Right? This gives you 2a n minus m, and this gives you what? See, over here it was d m n minus 1 minus d n m minus 1. So eventually you get what? d m n minus 1 minus d n m minus 1. You just need to sort this out. This is 2a n minus m. Fine. And on the right hand side you have d. If you take out common, you have mn minus m minus nm plus n. So plus mn minus mn cancels out. This is d n minus m. This is 2a n minus m. You get 2a equals d. I need to find the ratio of the mth and the nth term and prove it to be equal to 2m minus 1 is to 2n minus 1. Ratio of the mth term with the nth term, that is a plus m minus 1 d upon a plus n minus 1 d. D is given as 2a. Again d is given as 2a. So what do you get? You get a plus 2am minus 2a upon a plus 2an minus 2a, which gives you a common 2m minus 1, a common 2n minus 1, and you have got that the ratio is 2m minus 1 is to 2n minus 1. Clear? Easy enough? Next question says find two positive numbers whose difference is 12 and whose AM exceeds the GM by 2. Now two numbers, let us assume them to be A and B. Let the two numbers be A and B. So let the two numbers be A and B. A minus B is given to you as 12. I can write this as root A whole square minus root B whole square equals 12. That is root A plus root B into root A minus root B is 12. Keep it as 1. AM exceeds GM by 2. AM minus GM of these two numbers A and B is given to be equal to 2. That means A plus B by 2 minus root AB is 2. This means A plus B minus 2 root AB is equal to 4. This is root A square plus root B square minus 2 root A root B is 4. What is this? This is nothing but root A minus root B whole square is 4. So root A minus root B is plus minus 2. If root A minus root B is plus minus 2, I get root A plus root B into plus minus 2 equals 12 by second equation. So root A plus root B equals plus minus 6. Now root A minus root B is plus minus 2, root A plus root B is plus minus 6. So root A plus root B is plus minus 6. Let us take it as 6 first, and root A minus root B is suppose 2. In this situation, if you add these two, you get 2 root A equals 8. Root A is 4, A is 16, and B comes out to be in this case what? If root A is 4, 6 minus 4 is 2, so root B is 2, B is 4. In fact, even if you take minus 2 and minus 6, even then A comes out to be 16 and B comes out to be 4. So the two numbers basically with us are A 16 and B 4, that is 16 and 4, such that they actually differ by 12 and their AM exceeds the GM by 2. Last question says find the sum up to n terms of the series, which is this. Now carefully observe the first, second, third term of this series and try to decode the nth term of this series. Let Tn be the nth term of this series. What will be Tn? First term is 1 square, second is 1 square plus 2 square, third is 1 square plus 2 square plus 3 square, fourth will be 1 square plus 2 square plus 3 square plus 4 square. So nth term will be 1 square plus 2 square plus 3 square plus and so on plus n square. First term is sum of square of first natural number. Second term is sum of square of first two natural numbers. Third term is sum of square of first three natural numbers. So nth term is sum of squares of first n natural numbers, which is this, and I know this is equal to n into n plus 1 to n plus 1 by 6. Open this up, you get 2n square plus n plus 2n plus 1 whole upon 6. 2n plus n is 3n. So here you write 2n cube. This is 3n into n, so 3n square plus n whole upon 6. This is your nth term. The moment you have got the nth term, how to compute the sum up to n terms of this series? Let Sn be equal to sum up to n terms of this series. Then Sn is given by summation Tk, k going from 1 to n. That means add the first term with the second, with the third, with the fourth, with the fifth and so on with the nth. You obtain a sum known as Sn, and that is how you in the compact form with the help of summation represent it. What is Tk? Tk will be 2k cube plus 3k square plus k by 6. Right? Distribute the summation, we know this. K going from 1 to n, 2k cube by 6 plus summation k running from 1 to n, 3k square by 6 plus summation k running from 1 to n, k by 6. 2 by 6 comes out, you are left with summation k cube, k going from 1 to n, sum of cube of first n natural numbers, n into n plus 1 by 2 whole square. This is 2, this is 3 plus 3 by 6 again comes out, you are left with summation k going from 1 to n, k square. Sum of square of first n natural numbers, it is n plus 1, 2n plus 1 by 6, this is 2. 1 by 6 comes out, you are left with summation k running from 1 to n, sum of first n natural numbers, n into n plus 1 by 2. Clearly n into n plus 1 by 12 is coming out common because this is n into n plus 1 whole square upon 4, 4 into 3 is 12. So n into n plus 1 by 12 comes out common, from here you are left with n into n plus 1, from here you are left with n into n plus 1 by 12 is common, so you are left with 2n plus 1, n into n plus 1 by 12 is common, so you are just left with 1. This gives you what? Okay, so this gives you what? N into n plus 1, 2n plus 2. So eventually this is going to be turning out to be what? This is n square plus n plus 2n plus 2. So this is n square plus 3n plus 2, which is what? N square plus 2n plus n plus 2, which is n plus 2 plus 1, n plus 2. So you have n plus 1 into n plus 2. When you simplify this, right? This is the simplification itself. And eventually your answer comes out to be n by 12, n plus 1 square, n plus 2, and that is the sum up to n terms of this particular series. I hope all the questions were pretty nicely understood. Please revise them very nicely. That's it from my side. Thank you.